Hello everyone, for this tutorial video I like to explain how batteries actually work, as well as give an explanation of how cells work in series and parallel, and how it is similar to situations we already saw with simple resistors. You may have often heard, in non-electrical contexts, a battery refers to a cluster of gunsmen, like in the military. Or you may have heard, in schools and colleges, a battery of tests means a group of tests, usually in rapid succession. So this same logic should apply for a battery of cells as well. Namely, that a battery is not a single cell, but a group of cells. And so, I will explain how the voltages and currents work in them, given that I already reviewed how voltages and currents work for single cells. If you ever looked at a schematic or a diagram of a circuit, you will see that the symbol for a voltage source is not one pattern, but a repetition of a pattern, which looks like this. And each pattern individually represents one cell. So you should conclude that a combination of all these cells in a series is what a battery actually is. Although there is a problem too with this method, because the resistances add up in a series, as was discussed earlier. So this means if a voltaic cell has a known internal resistance, the internal resistance of the battery combination will be worse, which is usually not a big deal for most applications, but it is something to be mindful about. So it may be a good idea when you engineer your own circuits to wire a battery in parallel with the resistors or other components as appropriate, in order for the total resistance to be less in the overall circuit. But usually, this is all about things happening on a case-by-case basis. There is no good rule of thumb that works for everything. You will just have to make a judgment call based on what exact circuit you are designing. Now that I've explained how batteries actually work, I can explain more complicated factors that affect resistance, such as the wire diameter or wire temperature, over my next few tutorial videos. As just like with batteries, real wires have some resistance to them, which actually depends on many complicated factors, as I will highlight. Although in general, when you design small circuits like in phones, you don't have to worry about it too much, because of how small the wires actually are. In industrial applications, like if you want to be an electrician in someone's house, those details do become important, so I feel you should still learn about them. And then I will discuss how capacitors and inductors work, as well as an explanation of how inductors apply magnetism to generate the electricity. And then after that, I'll talk about complicated circuits that involve combinations of resistors, capacitors, and inductors. And then after that, I will talk about how semiconductors work, such as diodes, transistors, and integrated circuits, because they are important to the manufacturing of today's technology, as almost all laptops, phones, and similar electronic devices are almost made up entirely out of integrated circuits. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.